complex, cocking, pulling, we're going down.
We are continuing on with the MCT4C course. We are in the middle of Unit 4 and Lesson 17, Part 1 of 2. So we're down to the last couple of lessons here. So we have 4, 5, 6, 7 of these left to go, and we will have perfectly covered the course. The last lesson will be just a review of Unit 4. And so today we're going to be having a look at imperial and metric measurements as well as so in general, what we're going to be looking will be ratio calculations, understanding the imperial measurement system, which surprisingly takes quite a bit of time to do, converting units within the same system, which is what we're going to use ratios for, and understanding the metric system. And in general, we'll know things have gone well if you're able to create a conversion table to help create ratios to solve for these things. So there's a couple of calculations that are going to be quite common, so we're going to solve those first. So example 1, we have some fraction calculators, and we're going to be asked to simplify the following. And so you might be thinking, is the answer to this one just 4? Yes. So if I take in my calculator 300 divided by 150 and then multiply it by 2 afterwards, I do indeed get 4. Today we're going to be using the Desmos scientific calculator. So again, all you need to be able to do is to be comfortable with typing these things in. So if I have 1,000, 1,000 divided by 250 multiplied by 5, we get this one, the answer is 20. And it's perfectly okay to just type these into your calculator all at once. For letter C, we have 10 over 20 times 1. That's merely 0.5. And for the last one here, I have 1,200 divided by 20 and then multiplied by 8. So if I take 1,200 divided by 20 multiplied by 8, you end up getting 480. And for these kind of calculations, when you're at the step where you just have to simplify it down, you don't need to show multiple steps, just one calculator solution is fine for this. And so the kind of calculations we're going to be solving are these ones. So these are ratio calculations, and we'll be solving variations of this all throughout this lesson as well as the next lesson. So we're going to solve for the missing value in each case. So in general, when we're looking at these ratios, we're trying to solve for a specific value. Say A over B is equal to C over D. And the method we're going to be using to solve these will be the means and the extremes. So essentially, you multiply the opposites together and equate them. So it'll be A times D equals B times C. The only stipulation is we say that B and D cannot be equal to 0. Then from here, we can just divide by either A or D or B or C to go ahead and isolate that variable. And that's the strategy for all of these. So when we're going to solve for the following in this case, we have x over 450 is equal to 10 over 30. We use the means and the extremes. So it'll be x times 30. So that'll be 30x is equal to 450 times 10. Okay. Now at this point is divide both sides by 30. And so my answer will be whatever 450 multiplied by 10 divided by 30 is. And this looks like it's going to be 150. Yeah, we get this 150. And all calculations will look something like this eventually. Okay, so for letter B here, we have x over 24 is equal to 5 over 40. So again, we'll use the means and the extremes. And so this will be x times 40, which is 40x, is equal to 24 times 5. So I'll just put 24 bracket 5. And then we divide both sides by 40. I think this is 3. And so let's have a look here. So on my calculator, I'm just going to take 24 multiplied by 5 and divide that by 40. And so we get x here is equal to 3. I wrote, say, over 7. Still the exact same setup to the beginning of the question, but when you go to solve it, you can simplify this down. So we have here in this case, if x over 3 is equal to 4 over 7, then we could say 7x is equal to 3 times 4. You can simplify that and make it 7x is equal to 12 if you would like. I don't see any need to, just because if I have to use the calculator more than once, I just prefer to use it once where possible. And then we divide both sides by 7. So here the answer is 12 on 7. But in case you're curious, as an exact answer, this is about 1.71. Okay, so now let's go ahead and move so we had the x in the top left corner of our ratios. Let's move it to the other 3 locations and see what changes. So what about the case where we have 4 over x is equal to 8 over 15? Use the means and the extremes. So we're going to have 4 times 5 will go on the left. On the right, we have 8 times x, so it'll be just 8x. And then we divide both sides by 8. So we'll have 4 over 15 divided by 8 is equal to x. So x will be equal to 4 multiplied by 15 divided by 8. So this will be 7.5. So the only thing that difference is, if you notice when we solve this, and I'll color code it for this one, I like taking the top left term and multiplying it by the term underneath the x, underneath the second term first. So in this case, if I have 6 over 7 is equal to 10 over x, my first step will be to multiply 6 times x. My second step will be to multiply 7 times 10. So at this point, we isolate for x by dividing both sides by 6. So x will be equal to 7 times 10 over top of 6, which is some number, 41 point something. Let's go figure this out. So we have 7 times 10 over top of, so over top of 6. So we get 11.66 repeating. So we'll just put 11.6 repeating is good enough for us. Or if you want to, you can round that off to make it 11.7. It doesn't matter too much unless the question says otherwise. Lastly, but not leastly, we have 9 over 10 is equal to x over 3. So again, using the strategy of the means and the extremes, we're going to take 9 multiplied by 3, and that's going to equal to 10x. Divide both sides by 10. So we end up with 9 multiplied by 3 divided by 10 is equal to x, in which case we're going to get 2.7 is equal to x. And we can use our calculator to verify. Try not to be a hero for these things. Feel free to just use a calculator for these. It certainly makes it a lot easier. And so yeah, we do get 2.7, and that's going to be our solution here. Okay, let's continue on. Canada adopted the metric system. So we've been using this for about 50 plus years. The metric system is based on units of 10. So we know that there are 10 millimeters in 1 centimeter, and that there are 100 centimeters in 1 meter. We also then know, consequently, that there's like 1,000 meters in a kilometer, because it's based on powers of 10. However, construction, such as house building and manufacturing, such as cars or clothes, still use the imperial system of measurement. That is due to our neighbors to the south, who are using the imperial system, and consequently we have to know it as well. And even today, people still generally refer to themselves in feet, inches, and pounds. And so what I mean by that is, if somebody asks you, or you ask somebody how tall they are, they might reply 5 something or 6 something or what have you. If you ask somebody their weight, they're going to tell you that in pounds. But if you ask them what they turn their oven to warm up, they might say 350 Fahrenheit, but if you ask them the temperature outside, they might say it's minus 30 degrees Celsius. So we have this like kind of weird system where we kind of mix all the measurements together, right? Because if I want to ask how far it is from Sioux Lookout to Dryden, you might say an hour or 80 kilometers. So there you go. The imperial system has a basic unit length that is the inch. So each inch is divided up into 60 equal parts, where one part is 1/16, two parts is 2/16, which reduces down to 1/8. The most common units of measurement in imperial system are denoted feet, inches, which is kind of these double hash marks, and feet, which is just a single one, yards and miles. There also exist other measurements between all of those. It's just that we typically don't talk about those measurements. So for example, there's things like league a league is 3 miles, as well as something called a chain. And all of these measurements were based upon farms, I believe, at the time. And so we're going to have a look at the tape measure. So here, most common tape measurements look like this. So on one side of the tape measure, it's going to tell you what this is in inches. And on the other side, it's going to tell you what this is in what this looks like. And also because taking the MCT4C course, they actually will end up in a field where they need to be experts at this. And so might as well just cover this as a review. And if this goes well for you, so be it. The centimeter side is relatively straightforward to go through. So for example, if I tick off this mark right here, we can see that this unit of measurement appears to be 1 centimeter of some kind, and then 1, 2, 3, 4, 5, 6.7 of a centimeter. That's it. So we have full centimeters, and then we have parts of centimeters. So if I want to know, let's say this mark is down here, that appears to be halfway between 2 and 3. So we would claim that this is 2.5 centimeters. However, when it comes to inches, not so intuitive here. So we already have a little bit of an unusual situation here where we're trying to mark off things between 0 and 1 inch. We've got a 16th. So every one of these dashes, large or small, is 1/16 in length. Then we have the 1/8, which is the middle-sized dash. So every 2 of those will be 1/8. Then we have the 1/4 inch. Those occur those are the next size dash up. And there's 4 of those. And then the 1/2 inch. So and I should mention as well that you can actually go smaller than this. And so we're going to restrict our study to be 16ths, but you can get measuring tapes that go down to 30 seconds. And if you're willing to spend some time, you can find one that goes to 1/64. Typically for most measurement situations, like you wouldn't need more than 16ths, but 32 and 64 might be more common for carpenters. If you end up taking courses, if you end up as a machinist, they care about a lot more accuracy. And so it's still based upon a similar system, but you might need down to like the 1,000th of an inch accuracy. And you have to have a special device to help you with these ones that I labeled in red. The 512, the 1,024, and the 2048. Very precise. Which makes sense if you're trying to create a nut, you want to make sure, or a bolt, you want to make sure that it fits perfectly properly. Okay. So we're going to spend the next few part here. We're going to review the different portions of the increments, starting with the 1/2, then going 1/4, 1/8, 16th, and then we're going to show you what this all looks like, and we're going to read a ruler and kind of figure this out. Okay. So for 1/2 inch, so I should mention before we even talking about 1/2 inch, there is the full inch. So full inch, you can see it's just kind of marked along this ruler here along the top. There's 1, there's 2, there's 3. So those are the full inch. So what happens exactly the middle way or halfway between an inch is what we call 1/2 an inch. So these are often written as, say, 1 and half inch, like such. They use the short form for this. In form, or use one of the other analogs, we might say, we might write out the word inch, or write this as 1 1/2 short form. Any of those are fine. Just make sure you have the double marks there. So the middle way between each inch is what we call half an inch. So halfway between 2 and 3 would be 2 1/2. Halfway between, say, 4 and 5 would be 4 1/2. Okay, so most people quite happy with the half inch, and you could see like mark it on a ruler pretty easily. Next one up is the 1/4 inch increment. So here, if you notice, we don't label the half, even though that's part of it. So for example, this marker here is a half. This next marker here is 1 1/2. And this next marker is 1 and, oh, sorry, not 1, 2 1/2. And the reason for that is because if you have a look at what should be there, which is 2/4, 2/4 reduces down to 1/2. And you can see the difficulty that emerges pretty quickly with these is that if you're trying to count these along, you need to have your fractions reduced as much as possible. Okay. And so here, so you can see where the quarters are, they lie 1/4 of the way through along an inch. And typically for these rulers, they tend to size these a bit differently, so it's easier to see what they're going to be. Next one is the 1/8. These occur halfway between each of the 1/4 inches. So if I have a look here, here's the half inch, here is the 3/4 inch, and halfway between that is an eighth. So in this case, that's going to be 5/8. And you might start to notice a pattern with these that was not obvious, let's say, with the quarters. But for the 1/8 inch, if you notice here, we have 4 of them that occur between 0 and 1, or 1 and 2, with 2 and 3. And it starts off as 1, 3, 5, and 7. That's not accidental. That's actually what it is normally, because if you end up with an even number on top, that means that could have reduced down to something else. So if I have 2/8, it's not actually 2/8, it's going to be 1/4. And as a couple of friends told me when working construction or working on roofs, if you tell somebody to cut off 2/8 of an inch, they're going to look at you a little strangely. So make sure you have to be able to reduce those if possible. Similarly, if you have a look at, say, every little tick mark, and again, most rulers are 16ths, but there could be more. You could have the situation where, again, you can see we are going up by 16ths, but we start with 1/1, 1/16, and then we move 2 notches to get 3/16, 2 notches, 5/16. If you notice, we just increase by an odd number all the way up to 15, and that's kind of the end of it. Now, you might be thinking, if we reduce down, would that mean we would start with 1/32 and then go 3/32, 5/32, and so forth, all the way up to 31/32? That's absolutely correct, and what would happen because of how we want to reduce down these fractions. Okay, and so the difficulty with these is that you end up having this sort of structure. So if you have a ruler between 0 and 1 inch, you have the situation where the middle is going to be 1/2. Between 0 and 1/2 and 1/2 and 1 are the quarters. And halfway between, or the middle point between the quarters, are all the eighths. And the halfway point between the eighths are all the 16ths. So this is a fairly useful diagram if you ever have to try to figure out what these are in your own life. And if you've never had a chance to kind of look at these before, this is actually a good lesson to kind of pause, try out, kind of get the handle for, and so forth. Because you can compare this diagram directly with the one we're about to do and kind of pick out your own measurements. We don't spend as much time on the centimeter side because it's a lot more intuitive. Because again, if I were to pick off, say, this point right here, you would say that on the centimeter side, well, it's 6.2 because there's 10 millimeters in 1 centimeter. So this would be 6.2 centimeters or 62 millimeters, depending on your point of view. And so for example 3, we're going to be reading a tape measure and we're going to indicate the length in inches of the marked measurements. And so I've crudely drawn little triangles above these to kind of point where they have to go. And I just kind of listed these all the way along. Okay. If you want to, you can say pick a point. You can say like have a look between the 1 and 2, and you can label what these are all supposed to, if you would like. So there's an eighth, there's an eighth, there's an eighth, there's an eighth, and so forth. If you would like to do that, you can. Or you can just refer to the nice little cheat sheet above that kind of has these. And eventually over time, you just, once you practice it enough, it'll stick and you'll remember forever. Okay. So let's try this first tick here. So we can see that this is halfway between the 0 and the half. So that means this is going to be, this is going to be the first quarter. Okay. But if we look kind of afterwards, this next tick mark, this occurs exactly this occurs exactly one little tick after the half. So this is a 16. So how big is it going to be? Well, we know, and this is where this chart would come in handy. We know that right after the half is going to be a 16th, and then that'll be 9. So if you were to count the little ticks all the way through, this would be the 9th over 16th one. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and this would be the 9th one. Okay, what about this next one? This one appears to be on the quarter again, because it's halfway between 1 and the half inch. And in fact, it is, but it's actually going to be 1 and 1/4. What about the next one here? Well, we can see that it's halfway between the quarter and 2, so that means it's going to be on an 1/8. So this will be 1 and if you have to check kind of see where it is on the map, you can see that it's like that second last large tick, or the last large tick, I should say. And so we can see that it's 7/8. Okay. What about here between the middle way between 2 and 3? That looks like it's going to be a half. So this will be 2.5 inches. This tick lands directly on the 3, so that's just 3 inches. And this last one here is kind of a little bit off the screen. So how do we read what this is? Another technique you can do is actually just start kind of count how many ticks over it is. So you can see here, this is 1, 2, 3, 4, 5 of these, and it occurs every 16th. So this will be 5/16, but we start with 3 inches of that. So this will be 3 5/16. Okay. Again, a little bit tricky for these things, but I do find it worthwhile to review, just because if you never spent a lot of time looking at these, then this looks strange the first time, especially if you have to read like a blueprint of some kind. Then this becomes quite difficult to read and interpret. Okay. So again, you can use this little cheat sheet. And if you need to, if you require more in-depth measurements, you just add another layer between all of these. So just add a middle point between all of the little ticks. Those will be your 32. And you start with 1 and you just go up by 2 all the way up to the last one, which will be 31/32, and so forth. So at this point, I would encourage you to kind of mark your own spots and try these out for yourselves to compare what you think they are, and check them against this little cheat sheet for where it kind of exactly lines up. And you should be okay. All right. So so that's the business of conversions and using the ruler. And so now I actually just want to do some conversions. So we're going to use our calculator here extensively. So the textbook uses this table to kind of help us along. And basically it's just a no-need table. And so we fill in on the left side what we know, and we fill on the right side what we end up needing. Okay. So let's have a look at this in action. We want to convert 6 feet to inches. So we have a little chart up here that can help us. And so we can see that for the metric system, and this doesn't list all possible measurements, this just lists some of the common ones for us. There are 10 millimeters in a centimeter, 100 centimeters in a meter, and 1,000 meters in a kilometer. This chart comes directly from the textbook, so do use that one in your calculations because the answers are also based upon these exact numbers. Okay. For the imperial system, there are 12 inches in a foot. That's the one we're going to use. 3 feet in a yard, and then 1,760 yards in a mile. And then we can also convert between the systems. So we can say 1 inch is about 25.5 millimeters, which is also going to be equal to 2.55 centimeters. 1 foot is equal to 30.48 centimeters. 1 yard is equal to 0.9144 meters. So a meter is longer than a yard. And a mile is about 1.609 kilometers. And all the questions we're going to be looking at will use these approximations, or the question will give us a number we should be considering. Okay. And so here we want to convert 6 feet to inches. Well, we know that there are 3 feet. Oh, try this again. We know that there are 3 feet in 1 yard. And we want to, we need to go to inches. Oops, sorry, my mistake. I thought we were going to yards. So we know that there are 12 inches in 1 foot. And we need to know how many inches there are for 6 feet. Okay, so you can see how I line this up. And it doesn't matter how I orientate this. So for the next example, I'm going to I'll reverse what it looks like. So I'll put the foot here, the 12 inches below. But if you notice here, we just say, what do we know? Well, there's 12 inches in 1 foot. And what do we need? How many inches are there in 6 feet? So what do I mean by a ratio then? Well, when we set this up, we can write this as 12 over 1 is equal to x over 6. That's it. The key to making these things work, make sure that your measurements line up correctly. So they both say feet on the bottom or both say inches on the bottom. And we just take our values. Okay. Solving this equation, we've solved this one already. We use the means and the extremes. So we're going to end up with 12 times 6 is equal to 1 times x. 12 times 6 is 72. So there are 72 inches in 1 feet, in 6 feet, sorry. So this would be 72. Okay, and that's it. That's like the prime, that's what we're going to be doing for the rest of the lesson, is applying this chart in various ways and going from there. Okay, so at this point, it'd be a good time for you to pause the video, try out the next couple of questions, and see how you do. Okay, so for this one here, again, I didn't make a big deal about where I substitute where the feet were or substitute where the inches were. I just said, all I know is that 1 foot is 12 inches, and I want to know how many 7 feet are. Well, that means I should put the 7 feet up below, and I'm looking for my answer in inches, right? So that the feet line up, and then the inches line up. Okay, so setting up my ratio, we're going to have 1 over 12 is equal to 7 over x. So we've solved this kind of question before, the means and the extremes. So this will be 1 times x is equal to 12 times 7. So x will be equal to whatever 12 times 7 is. So that will be 84 inches. So again, pretty straightforward technique. That's all we got to do. And you can also set up the means and the extreme chart from the calculation here itself and kind of see what it's supposed to look like. The textbook makes a big deal about making sure you understand how to do this because they don't want you to have to start guessing whether you should be multiplying by 12 or dividing by 12. As long as you just set up what the ratio looks like, it's going to work every time. And then inevitably, once you've done enough of these, you'll be able to just know what you're supposed to do with respect to multiplying and dividing and so forth. Okay, what about 6 feet to yards? 6 yards to feet. Well, I know that there are 3 feet in 1 yard. So we know there are 3 feet in 1 yard. And we want to know how many feet are there in 6 yards. So feet and feet. So we have feet, feet, line up on top, yards, yards, line up on the bottom. And so we're looking to solve 3 over 1 is equal to x over 6. So we multiply 3 times 6 and multiply 1 times x. So 3 times 6 is 18. So there are 18 feet is equal to 1 yard. Okay. And the whole key to making this thing work is just making sure you have this little table here set up. Again, the textbook makes extensive use of it. Well, like for all the questions, so you should be okay for this. Okay. Let us continue on. Oh, so 453 feet. Okay. Earlier, 3 MBR. So here we will write our 3 feet in 1 yard. And let's actually just verse direct this because why not? So we'll say that 1 yard has 3 feet. And we want to know what's 453 feet. So how do I know if I do it wrong or not? Well, say 4 feet up here, and I put the x yards below. I know that my ratio is not going to be correct because I noticed that on the when I set up my chart, it says feet and yards, but they have to be the same. So that way I know that this is not going to be correct, and it has to be the other way. So I also will mention that it's extremely make sure. Okay, so we know we did this right because we can see that we have feet and feet, and then we have yard and yards. Okay, so set in our ratio we're going to have here 1 over 3 is equal to x over 453. So using the means and the extremes, we end up having 1 times 453 is equal to 3x. So then we just take 1 times 453 divided by 3 will be our x value. So x will be whatever 453 divided by 3 is, which will be 151. So x is equal to 151. I'm pretty stingy with the space here, so I end up doing this little arrow quite a bit. But for your own notes, just make sure you leave plenty of room for yourself. Okay. So the metric system is a lot more straightforward. So as long as you have the conversion measurements, you're kind of good to go. So here's what they look like. So we use a prefix system. So we have here, some of these might be familiar. It's a kilo, as in kilometer. Okay. You can also see a milli in there. Milli might be something like millimeter. We also milligram. So think about like a tablet of medication. Okay. We also can use this chart, say the middle, instead of this. This could be the unit liter. So you've heard of like a liter of milk or a liter of pop or what have you. And then you might have the term milliliter. So we end up reuse the same prefixes for all of these. When it comes to distance, we use those the most often. So you might hear of kilometers, meters, centimeters, and millimeters. When it comes to weight, you might be familiar with kilograms, grams, and perhaps milligrams. And when it comes to volume, you might have heard of the liter and the milliliter. Those are like the common measurements that exist. But the ones that do exist that are in between that are based upon powers of 10. So here, if we kind of start at this one, and we'll use, for our purposes, we'll use the kind of the meter to help understand this. So if we have 1 meter, there are 10 meters in 1 decameter. There are 100 meters in 1 hectoliter. There are 1,000 meters in 1 kilometer. And then from there, you get quite large. There are a million meters in 1 megameter, capital M, and there are a billion meters in something called a gigameter, capital G. And it keeps going downwards. You can also write these using scientific notation. So if you end up taking some science courses, this is also these as one. One 9 zeros. Not, don't quite quote me on that, but that's the kind of small distance we're talking about. Okay. But primarily, like the ones I kind of listed off to the side, these are the most common ones you would expect your average person to run into and to use on a regular basis. If somebody ever said, I have 35 centiliter beverage, I'll be like, what does that even mean? You'd say, no, it's 355. It's a can of pop. Okay. Let's continue on. And so to finish off for today, and again, today is a day I promise we actually finish on time. I listed off some common measurements for us. So we're going to be converting metric units within the same system. So here we have 1 meter is equal to 100 centimeters. 1 meter is also equal to 1,000 centimeters. A centimeter is equal to 10 millimeters. We saw that from the ruler. A kilometer is 1,000 kilometers. A kilogram is 1,000 grams. And of course, 1 liter is 1,000 milliliters. So let us perform the following conversions. So what about 10 kilograms to grams? Well, we can see that we know that 1 kilogram is equal to, oh, this should be meters. I'll go ahead and fix that up later in my notes, is 1,000. I was looking in the right spot, but then I wrote down the wrong one anyways. We know that 1 kilogram is 1,000 grams, and we're curious to know how much 10 kilograms are for 1,000 grams. So there's our ratio. And so we can write this as 1 over 1,000 is equal to 10 over top of x. So we multiply this out. 1 times x is equal to 10 times 1,000 using the means and the extremes. So 1 times x is just x. 10 times 1,000 is going to be 10,000. And these are going to be grams because that's what we were looking for. Okay. What about 1,350 centimeters to meters? So we can see that 1 meter is 100 centimeters. So we know that 1 meter, and let's this because why not? We'll say that 100 centimeters is 1 meter. And we want to know what 1,350 centimeters is with respect to meters. Oh, I should have put it the other way. It would have ended up there. That's okay. So again, we did this right because the bottom both meters, the top both say centimeters, and if the reverse was true, that's also fine. So we're going to set up our ratio. It'll be 100 over top of 1 is equal to 1350 over top of x. Using the means and the extremes, you multiply these out. So it'll be 100x is equal to 1 times 1350. So x will be equal to 1 times 1350 divided by 100. And on your calculator, you can use a calculator to figure this out, or computational power either is okay with me. Again, at this point, you get the same amount of mark for however you solve it. So this will be 1 times 1350 over top of 100. So this will be 13.5, and these are going to be meters. So 13 meters is roughly going to be 1,350 centimeters. And lastly, but not leastly, we want to go from millimeters to centimeters. So we can see that 1 centimeter is 10 millimeters. And so we know that 1 centimeter is 10 millimeters. And we're curious as to how many centimeters is 45 millimeters. Okay, and again, we set up what we know, and then we set up what we need. So setting up our ratio now, we can have 1 over 10 is equal to x over 45. So multiplying this out, we end up with 1 times 45 is equal to 10x. And so x will be equal to 1 times 45 over top of 10, which is going to give us 4.5 centimeters. And so that we're able to use the chart to go ahead and these working at next time we're going to be having a look at this section of the chart where we want to convert between systems. We want to go ahead and also start applying these to application questions, because we can start asking, we're curious as to farther distances and kind of real life applications rather than just sort of looking at these and going from there. Okay. So with that, I do thank you for your time. If you have any questions, comments, or concerns, do please feel free to reach out. But I'll see all of you next time, and goodbye for now.